Hello students. In this video, let's summarize Class 10 Science chapter, Metals and Nonmetals. Metals, including lead, gold, silver, and copper, exhibit fascinating physical properties that distinguish them from other elements. Here are some physical properties of metals. Metallic luster. When metals are in their pure state, they have a strikingly shiny surface, a characteristic referred to as metallic luster. This property makes them visually appealing and valuable. Hardness. Most metals, with the exception of mercury, exist as solids, and they display varying degrees of hardness. For instance, metals like iron, copper, and aluminum are relatively hard, while sodium is soft and can be easily cut with a knife. Malleability. Metals possess the remarkable property of malleability, allowing them to be hammered or rolled into thin sheets without shattering. This characteristic makes them ideal for applications like crafting aluminum foils and copper sheets. Ductility. Ductility is another unique property of metals. It enables them to be drawn into thin wires without breaking. Copper wires used in electrical cables are a prime example of this property. Conduction of heat. Metals like copper and aluminum are excellent conductors of heat, making them ideal for applications in which heat transfer is critical. Lead and mercury are bad conductors of heat. Conduction of electricity. Metals like silver, copper, and gold are superb conductors of electricity, facilitating their use in electrical circuits. High melting point. Metals generally exhibit high melting points. Tungsten, for instance, has the highest melting point among metals, while gallium and cesium have the lowest. Sonority. Some metals produce a ringing sound when struck against a hard surface, a property known as sonority. Brass is an example of a sonorous metal. Nonmetals and their physical properties. Nonmetals, including carbon, sulfur, iodine, oxygen, and hydrogen, exhibit contrasting physical properties. Here are some physical properties of nonmetals. States at room temperature. Nonmetals can exist as solids, liquids, or gases at room temperature, adding to their diverse nature. Brittleness. Most nonmetals are hard but tend to break easily, rendering them brittle. Lack of luster. Nonmetals generally lack luster, appearing dull in their natural state. Bad conductors. Nonmetals are bad conductors of heat and electricity except graphite. Chemical properties of metals. Metals burn in the presence of air, undergoing a chemical reaction with oxygen. This combustion process results in the formation of metal oxides. For example, magnesium burning in air produces magnesium oxide. Reactivity with oxygen varies among metals. Highly reactive metals like sodium and potassium can ignite when exposed to oxygen in moist air. Metals like iron and aluminum react with oxygen at room temperature, forming a surface layer of oxide. Precious metals like silver and gold do not react with oxygen, even at high temperatures. Metal oxides typically exhibit basic properties. However, certain metal oxides, such as aluminum oxide and zinc oxide, display both acidic and basic characteristics. These unique metal oxides, capable of reacting with both acids and bases to produce salts and water, are termed amphoteric oxides. Metals react with water, producing metal oxide and hydrogen gas. The metal oxide further dissolves in water, forming metal hydroxide. General equation is metal plus water gives metal oxide plus hydrogen. For example, potassium reacting with water yields potassium hydroxide and hydrogen gas along with heat energy release. Metals react with acids, resulting in the formation of salts and hydrogen gas. Example, zinc reacting with sulfuric acid forms zinc sulfate and hydrogen gas. Highly reactive metals can displace less reactive metals from their compounds in a solution. This displacement leads to the formation of new compounds. Example: zinc, more reactive than copper, reacts with copper sulfate solution, yielding zinc sulfate and copper metal. Reactivity series. The reactivity series is a list of metals ranked by their decreasing reactivity, with the most reactive at the top and the least reactive at the bottom. When a more reactive metal is placed in a solution of a less reactive metals compound, it will displace the less reactive metal from the compound and form a new compound. How do metals and nonmetals react? In reactions between metals and nonmetals, electrons are transferred from metal atoms to nonmetal atoms. This results in the formation of ions and the creation of ionic compounds. Example: sodium chloride is formed when sodium metal loses electrons to chlorine, creating sodium cations and chloride anions. What are the properties of ionic compounds? Ionic compounds typically exist in the form of crystalline solids. Sodium chloride, commonly known as table salt, is an ionic compound which exists as a crystalline solid at room temperature. Ionic compounds are hard due to the strong electrostatic forces holding anions and cations together. Ionic compounds exhibit high melting and boiling points. For instance, sodium chloride melts at 801 degrees Celsius and boils at 1465 degrees Celsius. Ionic compounds are soluble in water but generally insoluble in solvents like kerosene and petrol. For example, sodium chloride dissolves in water but not in petrol or kerosene. In their solid state, ionic compounds do not conduct electricity. However, they become good conductors when dissolved in water. For instance, sodium chloride does not conduct electricity in its solid form, but when dissolved in water, it becomes a good conductor. Occurrence of metals. Metals are widely distributed in the Earth's crust and are commonly found in the form of ores, which include oxides, sulfides, and various mineral deposits. Enrichment of ores. The initial step in metal extraction is enrichment of ore. This process involves increasing the concentration of valuable minerals or metals while decreasing the content of impurities. Various physical and chemical methods like gravity separation, froth flotation, leaching, smelting are employed depending on the specific ore. Extraction of metals. Metals are extracted from their ores through processes involving reduction reactions. These processes often use heat and chemical agents to obtain the desired metal in a purified form. The lower the position of the metal in reactivity series, the easier it is to extract. Metals with low reactivity, such as gold and silver, are typically found low in the activity series. They are unreactive and can be reduced to metals by heating alone. Metals like zinc and lead, which fall in the middle of the reactivity series, are usually found as sulfides or carbonates in nature. They are first converted into oxides through processes like roasting, for sulfides, and calcination, for carbonates, before being reduced to metals using suitable reducing agents like carbon. Highly reactive metals, including potassium, calcium, and sodium, are at the top of the activity series. These metals are very reactive and are obtained by electrolytic reduction. For example, sodium, magnesium, and calcium are obtained through the electrolysis of their molten chlorides. Refining of metals. Metals obtained from various reduction processes often contain impurities. To obtain pure metals, a common method used is electrolytic refining. In electrolytic refining method, impure metal serves as the anode, and a pure metal strip serves as the cathode. An electrolyte solution is used, and upon passing an electric current through it, impurities dissolve into the solution, while pure metal is deposited on the cathode. This process is frequently employed for refining metals like copper, zinc, tin, nickel, silver, and gold. Corrosion of metals. Corrosion is a natural process that affects various metals over time when they are exposed to certain environmental conditions. Silver corrosion. Silver articles, when exposed to air, develop a black coating over time. This change occurs due to a reaction with sulfur in the air, leading to the formation of silver sulfide. Copper corrosion. Copper, when exposed to moist carbon dioxide in the air, gradually loses its shiny brown surface and acquires a green coat. This green substance is identified as basic copper carbonate. Iron corrosion, rust. Iron, when subjected to moist air for an extended period, undergoes corrosion, resulting in the formation of a brown, flaky substance known as rust. Corrosion, particularly rusting of iron, can be effectively prevented using various techniques and methods. Some strategies for preventing corrosion are painting, oiling and greasing, galvanizing, chrome plating, anodizing, and alloying. So, with the completion of this video, we have comprehensively addressed all the topics in Class 10 chapter Metals and Non-Metals. Also, you can learn this chapter through NCERT solutions, NCERT exemplars, and revision notes, which are available in the EduRev app.